Okay, this is section 4-6, using more than one pair of triangles. I kind of previewed this in when we are doing 4-5, when there was a problem that if I try to make these two, you remember butterfly triangles? And then you have to make the other triangle congruent to make one of the segments congruent to prove that these are also congruent. So this is probably harder. Well, the overlapping triangles were also hard. So, but a lot of these diagrams are actually overlapping. So, you gotta stay focused and do a lot of practice. Okay. So let's start with the warm up. So you got some of these on the quizzes, something similar. So how do we get to x, for example? So this one, you can get this angle because these are linear pair. If you get this angle, you can get this because this is isosceles. Then you can get the vertex angle. Since this is 90 degrees, you can get this vertex, and then you can get this, and then you can get this. Okay? So you get used to this after you do some of these. Okay? So do these right now, and I will give you the answer. See if you get to that. This is 107, and this is 49. And this is 140. Okay, so make sure you can do these. Okay. All right, so objective 1. We are here now, right, 4-6. And this is 4-6. And all these are 4-7. Okay. In 4-7, you're learning all these different lines. Okay. I think 4-6 is harder than 4-7. Okay. All right. Prove two triangles congruent by first proving two other triangles congruent. Okay. So this section, the hard part is seeing it, which is kind of like only way you get it is with a lot of practice. Okay. All right. So here's the first example. Measure bangle 1 and measure bangle 2 are congruent, and measure bangle 5 and measure bangle 6 are congruent, and you want to make AC is perpendicular to BD. Okay, so to these make perpendicular, you want to make like one of these angles 90 degrees, or like if these two are congruent, then you can make this perpendicular by the converse of a perpendicular line theorem. So that's where kind of we are looking for, or maybe this and this. Yeah, that's probably more like it because this is probably congruent. This is probably congruent to this. All right, so here's a plan of proof. It may be helpful here. So like we were talking about, it may be helpful here to reason backward. So like we started with this, from what you want to prove. You can show that these are perpendicular if you can prove that 3 and 4 are congruent. If these are congruent, then these are congruent adjacent supplementary angles, and therefore line have to be perpendicular, right? And if you want to prove the 3 and 4 congruent, you want to prove the triangle ABO is congruent to ADO. And to prove these two triangles are congruent, you need AB is congruent to AD. And to make AB congruent to AD, you can prove that ABC is congruent to ADC, then these are corresponding sides of that triangle. And then you can prove these two congruent, and then these are perpendicular. Okay, it's getting pretty complicated. All right, so let's start with 1 and 2, and 5 and 6. That's a given. And then this is shared, right? So you got the angle, another angle, and then 2 segment AC is congruent to, do we need to flip here? No. AC, because this is not parallelogram, right? The corresponding angle, the congruent angle is on the same side. If this is on a different side, then you have to flip it. So that's its reflexive property. So the triangles are congruent. Make sure it's in corresponding order by angle, side, angle, postulate. So now those two triangles are congruent, then we can say that AB and AD are congruent, right? So AB, segment AB is congruent to segment AD by corresponding sides of congruent triangles are congruent. And then now that these are congruent, and then this is shared, and then what else we know? We know 1 and 2 are congruent, right? So now we go with, so now this was angle side for the first one. So let's see, 1, 1, 1. And then this is a side 2, side for the second triangle. And then this one is angle for the second triangle as well. And then we got the one in the middle shared. AO is congruent to AO, and that is a side 2. And that would be reflexive as well. Property. So now we can see the second triangles are also congruent. Triangle ABO is congruent to triangle ADO. And that was side angle side. Side angle side postulate. Right? Now that you said that, you can say the corresponding angles are congruent. So angle 3 is congruent to angle 4. And that is corresponding angles of congruent triangles are congruent. And 8, angle 3 and angle 4 are right angles. And this is congruent adjacent supplementary angles are right angles. Okay, congruent adjacent supplementary angles are right angles. Okay, you need these three: congruent, adjacent, and supplementary to make these two are right angles. Okay, so now you can say that AC is perpendicular to BD, and this is these are right angles, so that's the definition of perpendicular lines. So if an angle formed by lines is right angle, then lines are perpendicular. Okay, here you go. If the angles are congruent, lines are perpendicular. Yeah, all right. So that's the first one. So here's a summary of what we did here. So here's the key steps of the proof. First, you prove the larger triangles are congruent by angle side angle, and then you do AB is congruent to AD by corresponding, and then prove the smaller triangles are congruent by side angle side, and then you do the corresponding, and then the two lines form adjacent congruent angles, then lines are perpendicular. Okay, I like to add supplementary here just to make sure. All right, and here's how the paragraph proof will be written. Triangle ABC is congruent to ADC by side angle side, angle side angle postulate. Therefore, corresponding parts AB and AD are congruent. AB and AD are also corresponding parts of ABL and ADO, which can now be proved congruent by side angle side postulate. Now, here it's a lot of abbreviation, like you don't have the three parts that are congruent to make them. I don't like this. Okay, it should be said that which lines are, you know, two of those are given, so that's why they are abbreviating here. But if I tell you that if it's given you can abbreviate, you start to abbreviate other things. I would rather you writing three things here in paragraph proofs. So corresponding parts, angle 3 and angle 4 are congruent, and AC is perpendicular to BD. Again, this is a little bit short, very short of explanation. I want a little longer. Okay. All right. I will show you more examples of paragraph proof that are acceptable along the way. Okay. So here's a practice. So why don't I do 2 and then you try 1 and 3 for homework. Okay. And this is video. And then we do this in the video as well. Okay, so you see what you're supposed to do here. This is just your writing the reason why you can do it. Okay, so if you want to prove that AX is congruent to AY, you probably want to prove like these two triangles are congruent, or these two triangles are congruent, right? So that these are the corresponding side of the congruent triangles. So the key step of proof, this one is already giving you the key steps. The hard part is when you have to come up with it. So first, PAL is congruent to KAN. So you got the these are vertical angles, right? And then these are sides are congruent, and then sides are congruent at side angle side. So this one is side angle side portrait, right? And then angle L is congruent to angle N. That will be the corresponding. So let's just start using CPCTC now. CPCTC. Now you can use CPCTC. Okay. And LAX, the triangle LAX, is congruent to NAY because we already said that these angles are congruent, right? And then these angles are vertical angles, right? These are vertical angles. And then these are congruent by given, so it's angle side angle. And therefore AX is congruent to AY by CPCTC. Okay, so you try these, you just put in these reasons. Okay, so these are obviously just CPCTC, just practice of seeing how to do these things. Suggest a plan for proving D is congruent to F. Okay, so I want to stop the video here and I want you to try it because this is the first one you're trying on your own to see if you can make them, because these already gave you the means key steps, right? You have to come up with the key steps. Okay, all right, so let's see if you came up with the same. It's possible there are more than one solutions, but let's see. All right, so you want to make this and this congruent in the end. So either you make these two triangles congruent or these little ones congruent, right? Or you do these first. No, that doesn't help. Let's see. So you have two sides are congruent and these are congruent, but that would be side-to-side angle. So you cannot go straight here, right? So you have to make them, so you can do HL here, right? So these are right triangles, and the hypotenuse are congruent. No, you can't do that. Oh, sorry, it's angle side. It is angle side. So these are vertical angles and these are angles. So you can do CPE is congruent to DQE by angle side. So let's just write the triangle. CPE is congruent to triangle GQE by angle side theorem. Okay, so now these are corresponding side, right? And this is 90 degree. This is 90 degree. And let's see here. Which one's the corresponding side? This. Oh, so that's HL now. So this is 90 degree here, hypotenuse and leg. So these two triangles are congruent and therefore D and E are congruent. So you can say that segment PC is congruent to segment QZ, right? That's the order. The right angle star is right angles by CPCTC. Then you can make triangle DPC is congruent to triangle FQG by HL theorem. And then you can do angle D is congruent to angle F by CP CTC. Okay? How did you do it? It's fun, right? It's very fun. All right. I think this is where the homework starts. Alrighty. So we are done with the instruction part. The rest is just doing the problems. So I want you to do this, and then I want you to do some of them on your own. Well, maybe I might as well do this one, right? And all right, try this one because this is odd. Okay, so the whole mass is there, right? All right, so you do 1 3D. So this is homework. And you already did 2 of those in here, right? You did 2 of these on page 5, right? You were supposed to do these 2, 1 and 3. So just do 3 and 5, yeah. Okay, you do 3 for homework and 5 for homework and this one, okay? And we'll do the rest in the class. We probably spend 2 days on this, yeah. Okay, see you in class.